Learning is the key to unlocking the door to success. Make every lesson an opportunity to grow and develop. Calculate the divergence value of the vector field, A equals x squared I hat, plus xy j hat at point 1, 2. Okay, here are two-dimensional Cartesian coordinates. In this coordinate system, there is a vector field. Each point in space may have a different vector value. Let's say we want to calculate the divergence value at a certain point. This point is the center of the inspection area. We can observe the vectors that are around the boundary line. Around the line there are several vectors. Some vectors enter the inspection area, some vectors leave the inspection area. Now the measure of the number of vectors that pass through this inspection area is the divergence. The term divergence was chosen because the divergent lens is spreading light. Thus a positive value of divergence means that more vectors are leaving, or moving away from the inspection area. If the vector field is f1 I hat, plus f2 j hat, plus f3 k hat, then the diff of f is partial f1 partial x, plus partial f2 partial y, plus partial f3 partial z. Knowing the vector field, we can calculate the value of difference. Well, the first step is identification. The vector field A is equal to x squared I hat, plus xy j hat. So the component of vector A on the x-axis, A1 is x squared. And the component of vector A on the y-axis, A2 is equal to xy. The location of the point is 1, 2, meaning x is 1 and y is 2. The next step is to calculate the divergence of the vector field over all points. The diff of A is equal to the partial A1 partial x, plus the partial A2 partial y. Here we only use two terms, because the vector field has no component on the z-axis. The partial derivative of x squared with respect to x is 2x. The partial derivative of xy with respect to y is x. So the diff of A is equal to 3x. Now we can calculate the value of diff at a particular point. At the point 1, 2, the diff of A is equal to 3 times 1 is equal to 3. This value is positive, meaning that vector A is much further away from the test point. As an illustration, here is a vector field A. This is the location of point 1, 2. Consider the inspection area as a box. There are more vectors coming out of point A than vectors approaching point A. That is why the diff value is positive. Hopefully it is useful, and don't forget to watch the next video.